Now we have talked about what the equation under motion, talk about dimension analysis. Now let's go to projectile. Projectile. Now I told you that projectile has to do with what? Equation. It has to do with what? The motion of a body in a parabolic path, in a trajectory path. That's the path by which a body that undergo projection or projectory motion is what we call trajectory. The path at which a body follow a projectile motion is what we call a trajectory. Now, the projectile involves a body moving in parabolic form under the influence of what? Gravity. Now, for instance, if we shoot a gun or you shoot a catapult, it goes something like this and then it comes down. So here we have our velocity. We have the initial velocity here, u, which can be resolved into what? Ux. It can be resolved into uy rather. It can be resolved to ux and what? Uy. And sometimes they might what? Wanted to what? To u to the right, but it's on a rare occasion. So this one is what? Let me write it here. This one is uy, and then this one is what? Ux. So this one is velocity time what? Graph. Velocity time graph. Now, so here it's very important to know this. At this point here is maximum height. Maximum what? We have maximum height, which I denoted as what? H max. Maximum height. So they might ask you maximum height, and here is time to reach the maximum height. Time to reach maximum what? Time to reach maximum height. Reach maximum height. Please note that there is a time t to reach the maximum height, and when it comes back, that is t ordinary t. But when it comes to here, we have 2t. 2t, which is usually what? Time of flight to cover everything. Time of flight to cover everything. So time of what? Flight. Time of flight. So it's capital letter T equal to what? 2 what? T. So time of flight. This one is also projected at a specific angle. Don't forget, this is also at a specific. This used at a specific angle. That's why I draw it like that. So if they ask to calculate all these parameters, the distance, the horizontal or distance, is what we call what? The range. This diagram is just summarizing the what? The projectile motion. So the range. So how do you now go about the calculation here? When you are asked to calculate the time to reach what? Maximum height. That's the first question they might ask you. Time to reach the maximum height. Time t. When I use small letter t, time t to reach the max, it means time to reach the maximum height, which is equal to u sine theta over what? Sine theta, u sine theta over what? G. That is the formula for calculate time to reach the maximum what? Height. So please note that. Then capital letter T is 2t, right? Which is 2u sine theta, right? Sine theta over what? G. Don't forget that this G is acceleration due to what? Gravity. So from here, we move towards maximum height itself, which is equal to u squared sine square theta over what? 2g. Over what? 2g. This is over 2g ordinary g. Let's check out. From the equation of motion, S equal to ut squared, ut plus half at squared. You don't need to know this one. I'm just trying to compound something. If we put u sine theta over what? Over g, it's going to be what? Okay, it's going to be what? 2g. U squared sine square theta over what? 2g. So we have the range. R equal to u squared sine 2u 2 theta sine 2 theta all over what? G. This is the range. So these are the formula for calculating what? So if you are not given what, there are sometimes it might not give you what angle. Just remove the angle and say u square over 2g, 2u over g, u over g, u square over what g. There are sometimes you are not going to be given angle. So note that. So you just remove the word angle is going to give you what u square over g, 2u over g, u square over 2g. So that's that about what projectile. It's quite a simple what question. It's quite a kind of simple question. So make sure you note that and tackle it very well. You see them, it's very simple. This is our projection. I told you if you are not given angle, just remove this sine theta, sine square theta. Just use the word 2u over g, u square over 2g, u square over g, and so on and so on. So that's that about projectile. They can ask you about what the application of projectile, the what that is the catapult, the what the shooting of catapult, the shooting of a bullet, and what and so on. The discourse, training of discourse and javelin. All these things are application of projectile, and they can give you questions and calculation on it using this formula. So that's that about projectile to save our time. The next one is what is the is number 4, which I use what W to represent. Which I use W to represent. Okay, number 4. What I use W to represent my poster. So if I didn't remember very well, if I remember the right time, I would work done energy and power. Work done energy and power. I know that one is to be work done energy and power. But let's move towards to AC circuits. AC circuit. That is alternating what current. This is a powerful topic that usually carries marks. AC circuit has to do with what? Has to do with current moving in the what? Current moving in what? Different what directions. That is T and then I/V. Now what does that mean? That is, it's a current whereby it's a current flowing through a circuit, changing what periodically. When a current flowing through a circuit or when a current flowing through a conductor changes periodically, then we say that current is an AC current. While a direct current is a current whereby the current flow in one directional path. The direct current flow in one directional path. But this one, it changes periodically. That's why it's forming sinusoidal curve, a sine graph. Sinusoidal current. So that's why we usually calculate what the root mean square current and the root mean square voltage, because of the changes is usually what I equals to I naught sin theta WT, because this one has phase angle. I equals to I naught, if there's something called I equals to I naught sin W T, and V equals to V naught sin W T. But the major formula, this one is not actually what necessary. The major formula is when you have I root mean square equals to what? I naught over root what? 2. You call this one the root mean square velocity, and this one is peak. The peak current. The peak current. So also it's applicable to what? The root mean square voltage is equal to what? The peak voltage root what? 2. Please know these two formulas, they are very, very essential. So here you move from the current flowing to a circuit, which is an AC circuit, the root mean square to I naught, the root mean square is also for voltage is V naught over what? Root what? 2. Now they can now move to what? The type of what? Series. Type of series, or the type of circuits. Type of circuit arrangement, type of circuit based on the arrangement of what? Of the capacitance. Type of circuit based on the arrangement of the capacitance, the inductance, and what? And the resistor. Now we have this where the major question is always being asked. The first thing is to understand that before we enter into what? Circuits, you need to understand that we have some component of what? You have the component of a AC circuit. Component of AC circuit. component of AC what circuits. We have number one, we have the inductor. Inductor is like this. Inductor represented by L, capital letter L, generally denoted by capital letter L, inductor, and the unit is in Henry, H. Inductor, we have the what? The capacitor is like this, capacitor C, represented by C, and the unit is Farad, 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 Farad. So now the other one is what? The resistor, which you are familiar with, so to say. We have the what? The R, which is represented with ohms, ohms, which is the unit is ohms. So we also have the symbol for alternating current. When you see something like this, it means an AC current is flowing through, just like a sinusoidal graph. So now we also have, they will give you frequency. Frequency is always given here. Frequency, they will write beside the voltage. Beside the voltage, verify the voltage source. So that's the major thing when you see that. So there are different types of from the circuit now. So the AC circuit components here, there's something we now call the resistance. We call it the reactance. The reactance of a circuit. Reactance of a circuit. Now it depends. Now we're talking about reactance. Just as we have what? The resistance. We have reactance also here. And the reactance is of two types based on the inductor and the what? This, I told you, this is inductor. Inductor. This is what? Capacitor. This one is a resistor. So based on the inductor, the reactance for inductor, the reactance produce, just as the resistor produce resistance, the inductor produce inductance. So now, and to calculate that inductance reactance, we represent it as XL. XL, which is same as 1, is represented as WL. XL, which is the inductance reactance, is given as XL equal to XL is same as what? W, this is the omega what? This is an omega, this is what we call angular velocity, 2 pi F A. Please know that. 2 pi, we call it what? Inductance. Inductance. So this is inductance. So please know that this one is inductance reactance. This is what I just did, is inductance reactance. Okay, or inductor reactance, whatever I want to call it, just an English word. So the other one is XC. XC. XC has to do with what? The capacitance. This one has to do with capacitance. Let me write, I'm doubling it so that you know that this one is different from this. So this one is capacitance, which is XC is equal to 1 over W what? C, which is said as 1 over 2 pi F C. 1 over 2 pi F C. So please note this. Very, very, very important. Note this. So now, with these two things now, we now move towards the type of circuit. If you have RL or circuit, that is a circuit that contains what? The resistance and the what? And the capacitance. And the resistance and the what? The inductance. You might connect it to an AC circuit with a potential difference, and then they will give you F. This one is resistance, this one is what? L. You must know that they can also do something like that, and you might have to calculate the impedance. Impedance is the sum of the reactance. Impedance is the sum of, so because they give you this and this now, you can say the impedance for this Z equal to R squared plus what? SL squared. You know, R is just the normal resistance given to you, where XL is gotten from this. So that one is applied. So this we can also give you RC. RC can be resistors now, and then capacitor. That's what we call RC. They connect it to what? AC source. They will give you voltage and they will give you what? Frequency. So the impedance will be what? Z equal to square root of R squared plus what? XC squared. So that's the formula for what? Impedance. So now let me quickly clean this one and summarize it here. So I want you to note all these things I'm giving to you together. Just know this formula and know the applications and begin to solve questions on it. So now here we have what? Here, from here now, we have also another type of circuits, continuation from type of what? Circuits now. Type of circuits. We have what? The RLC circuit. This is very, very important. This one, they usually ask questions because of the calculations that is there connected to an AC circuit, voltage and frequency will be given. Here, the impedance is usually V equal to what? Square root of R squared, and then plus the lapse of what? XL minus XC all what? Square. It's very, very important. Also, the V is given as VR squared plus what? VL minus VC all what? Square. Please note that they always give VR. And know that what? The V itself is equal to IZ. This one is because the series, the same current flows through them. Because it is series, the same current flows through them, but different what? Potential. That's why this one is VR, VL. Yes, because the V here is VR. The potential difference across this. While the potential difference across this is VL. Why the potential difference across is VC. Please follow. But the same current flows through. The same I that starts here, that enters here, also flows through here. So please note that. So that's why you can calculate the VR from adding this up, but I is always constant. I is always constant, like in electric current. I is always what? Constant. So that's that about the AC circuit. These are what you will majorly see other calculations, and you can also use diagram to what? To represent what? The relationship between the potential difference of VR, VL, and VC. So if they combine the three together, the diagram looks like this. The VL here, VC here, we have then the what? The VR here. So that's it for the four, but they can also ask for the what? For other one like this and the likes like that. So these are whatever they usually what is the usual other what potential difference is very, very what? Important. So that's that about this simple alternating current. Now let's quickly move to what? To wave. Just remember now, wave. We have wave here. Wave. W represents what? Wave. So now wave is also a big topic, very, very big. Wave and light, they are very big topic. Now we're talking about wave. Waves are actually what? A big topic to consider, and wave is a disturbance that travel through what? That travel toward a medium, whether it's required material medium or it's also travel to air and so on and so forth. So wave is a disturbance. We always say that in primary school, that when you are in secondary school, you are a disturbance, you are a wave in the what class. So now majorly we have two what type of wave. We have the what? The mechanical what? The major classification of wave is mechanical wave, and what? The electromagnetic what? The electromagnetic wave. The electromagnetic wave. Now, we're talking about the mechanical wave. It's wave that travels through material medium. This mechanical wave can also be divided into what? Two. The longitudinal, the transverse, and the longitudinal. Don't forget longitudinal. This one is what? Mechanical wave, which travels through material what? Medium. This one requires no what? No material medium. No medium is required. No material what? Medium. Now, so mechanical wave require material medium. This one requires material medium. Transverse wave is a wave whereby they are, I can ask you to give example under material medium and what. This mechanical wave is sand, water waves, and so on as water waves, sand waves. They are all mechanical waves. While electromagnetic has to do with microwave, X-ray, and so on and so forth, they are under electromagnetic wave. Now, under transverse wave now, transverse wave has to do with what? Has to do with waves in which the vibration of the particle itself is perpendicular to the travel of the what? Of the particle, in which that is the vibration of the particles of the wave of the material medium is perpendicular to the direction, that is at right angle to the direction of travel of the wave. So the vibration of the particles, they are at 90 degrees to the what? To the direction of the wave that caused the vibration. So that's why we call it transverse. An example of transverse are usually what? We have what? The water waves is also a transverse. Water waves is transverse. We have water wave is transverse, very, very important. Like the light wave is also a transverse wave. Light is transverse. Why longitudinal, in which longitudinal is what? Is a wave in which the what? The vibration of the molecules or the particles is in direction, it's the same direction to the what? To the direction of the wave. It's the same direction to that of wave. The vibration of the what? Of the material medium for a longitudinal wave is in direction to the what? To the wave travel, to the what? To the wave direction of the to the travel of the wave. Right. That's it. Please note that a longitudinal wave is a wave whereby the vibration of the material medium through which the wave passed through is the same to as the what? The direction through which the wave passed still or traveled through. So that is that. So just know that one have perpendicular direction to the particle what? Vibration, while the other one have what? The same direction. The wave has the same direction to the what? To the vibration of the particles. So this one is usually sand. This one is usually what? Water waves, light, and so on and so forth. Water wave, light wave, and why something like sand. Sand is very interesting topic, but I'm not going to go into that now. So that is that about longitudinal and transverse wave. We also have other types of wave like stationary wave. Stationary wave or a standing wave, whereby I think is one of it is one property of standing wave. You must go and read it very well. It's very, very important. They usually ask questions. And let me now move to what? The properties of wave. Very, very important. The properties of what? Properties of wave. Properties of wave have to do with what? The reflection, the refraction, the diffraction, the interference, and the last one, which is not that common with all waves, which is specifically for transverse wave, plane polarization. So you have to go and study this very well. Reflection has to do with what? The light being reflected by a substance, usually with a surface mirror. And refraction has to do with what? The changes light undergoes, the change in the speed of light when it travels from one medium to another. Refraction has to do with what? These changes in the speed of light or the speed of wave, the changes in the speed of wave as it travels from one medium, from either air to glass, or from glass to air, or from air to water, or water to air. So it is the changes in the speed of wave as it travels from one medium to another. Refraction is a very interesting law. It's a very interesting what? Reflection is way by which what? The waves are being what? Given back when they hit a particular surface. And we have law of refraction and reflections. So note that one's next law of what? Refraction is very, very important. They might ask you as well. So and how to calculate what refraction and reflection. So diffraction has to do with what the process by which wave pass through a obstacles, the way they move around a obstacles. When the wave encounter a obstacle, the way they move around the obstacle, how they pave their way around obstacles is what we call diffractions. Diffraction. How wave move around obstacles, and it has to do with what? It has to do with what the light actually undergo diffraction in such a way that they become scattered. They become scattered when they undergo obstacles. While in the sand out become white when they undergo obstacles. So anyway, each individual waves have their own characteristics around diffraction. When they undergo diffractions, like light waves become obviously distracted and diffracted. That when light wave, when they on meeting with a slight or small obstacles, while sand maneuver their way when they meet a big obstacles. So now interference, we have two types of interference. We have the interference which has to be constructive interference, and destructive. What does it mean by constructive and destructive interference? Now, interference is when two waves moving at the same frequency, they are when two waves moving at the same frequency are superimposed. That is, they are moving at the same frequency and they are superimposed. Now, they are constructive interference when they are moving in what? When they are moving in one of these directions, this one, another one, and they reinforce each other. So these are called constructive interference. You can use diagram to explain to them. Constructive interference. So in this case, the wave help the other to amplify its own power. They help each other out. While constructive interference, they will move at opposite frequency, like this one, like this, they form a loop, something like a loop. So in which the effect of one cancel the other. So that's what we call destructive interference. This one is constructive interference. And plane polarization has to do with how you can polarize light with polarized light waves. So these are the examples of properties of. We're going to read about standing or stationary wave, as I've said earlier. So we'll go to wave equations. Wave equation and motion, right? Which are the major also major part of question under wave. Number one we need to know is that we have general wave speeds, which is v. Now, normally the diagrammatic representation of a wave looks like this. So it's in a sinusoidal curve where we have the x against t, the displacement against time. We call this one the crest, the trough. We have the magnitude, the amplitude rather. Amplitude is just the maximum velocity. So we have also from here to here to be a complete circle. And here we have lambda. We also have capital letter T here, which is the complete circles. Period is for a complete circle. Is the time taken for a complete circle, and this is a lambda, the distance of the distance, that is wave, we call it wavelength. Lambda, according to that diagram. Now we have wavelength lambda. Please know that wavelength lambda. We have we have the period T, time taken for one complete circle, and we have the frequency, which is the reciprocal of the frequency f. So that when I'm writing out the formula that you need to know, we will not be fan lost. So wave speed, which is v, is equal to lambda what f, which is same thing as what. Now that is the wave speed is equal to wavelength multiplied by what, frequency f. So we can, where we have what, frequency, where frequency is same as 1 over t, the reciprocal of what, of the period, and period itself is number of what, cycle per time, total number of cycle per time. So period, you can also define period as number of cycles over time, normal time. So that's that about that. So these are the little words calculation. They can calculate what, this and this. Then there's also called progressive wave. The question of what, progressive wave. Before I conclude this one involves huge workings. If I can go to workings, I will do some example for you if time permits me. Progressive what, wave. Equation of a progressive wave. Equation, progressive wave equation. We have what? We have the progressive wave equation, which is y is equal to a sine what? A sine of bracket kx minus what? W what? T. That is phase angle. Ks, this W T is the phase angle, where k is the wave number. Is given as k equal to 2 pi over lambda. W is the what? Angular frequency. This question they can come in form of 2 pi ft, and that's the W equal to 2 pi f. What else again? Because they can substitute these things inside it, can become 2 pi. So a sine 2 pi f, 2 pi over lambda x minus 2 pi ft, depending on how the equation comes. So application of this is very important. The calculations, you can also calculate amplitude from this, calculate what, the frequency from this, calculate the angular velocity from this progressive wave. Is a question that they usually ask in theory, and you need to know that. So we still have what, I still have a lot of things to tell you as far as physics is concerned, but now I want to stop for the continuation next time. Or if you have not yet, if you cannot wait too much, you can go through my videos. All this topic has been treated individually. So by God's grace, I'm going to upload another one if time permits before Monday comes. Stay tuned to this YouTube channel and keep on watching videos of academic tutorial. Thank you and God.